Okay, so this is the start of my video. So this shows off my boat game and the gameplay for my boat game. This is my boat moving forward and slowing down using deceleration and acceleration. As you can see at the top, the boat is actually accelerating rather than it just skipping forward. It gradually accelerates, as you can see from the top as well, and slowly slows down again. It has turning, as you previously saw. It turned around that buoy. The reason I've chosen the track I've chosen is a forward turn around said buoy move back, so that I have my turn in my track, and this shows off the main features of my game. In this scene, I will show you that to work out the velocity and the boat position. So I used last time, current time, and delta time variables, a float for acceleration, and a vec3 for velocity. This is my equation function for working out how to do the velocity in the boat position. As you can see there, the velocity is equal to the previous velocity plus the acceleration times the delta time. This first section of code here shows the exact positions and the values for the acceleration in the inspector. And so to work out the velocity is, as I said before, velocity equaling the previous velocity of so the previous position, the previous velocity that was there, so 0 in this case, plus the header times the acceleration, because that's the way you work out the acceleration in this, and then times that by delta time. And for the position of the boat, you do the previous position of the boat plus the velocity times the delta time, which is the velocity of the previous frame, and then you times that by 0.5, which in this case is half, times the acceleration, so header times acceleration again, times delta time squared. So to work out the current time, you use the code glut get glut elapsed time. Well, I'll give you the current time, and to work out delta time, you do current time, take away the last time, so the last frame, times by 1,000, divided by 1,000, I say. To work out the last time, it's current time equals last time, so that will be the previous frame is last time for current. So the previous frame for current time is equal to last time. I have an if statement. Oh, sorry, my mistake. I have an if statement. So if acceleration is less than or equal to 0, the acceleration will equal 0, and the velocity is equal to 0.9. This is a problem because I can't go backwards in my game anymore. It only goes forwards. But and so else, if acceleration is greater than 0, it will always decrease it by 0.05, so it will always slowly decrease in speed. If another few if statements. So if key is equal to W, the acceleration will increase by 0.175, and that will be redisplayed every frame. So every time you're holding the W key down, it will go forward. The same with the S key, except the acceleration is decreased by 0.175 each frame rather than being increased by 0.175 each frame. Now, to do the turning, I use the A and D key, and so when you click the A key, your boat will turn clockwise, as you can see in the little clip I've got playing there, and if you click the D key, it will turn counterclockwise. It does this by taking the header value and making so it turns the mesh by 0.75 degrees. It will then you'll then rotate your header as well by the same amount in radians, and then it will normalize that to the new position. So if you're facing, say, like towards one of the buoys, you'll be normalized towards that buoy, and then you'll be able to move forward in that direction. It's the same with the D key, except it's a minus value rather than a positive value, because that way, it takes away rather than increases, because that way it will go the counterclockwise direction rather than the clockwise direction. And then it redoes this every frame, and that is how you work out the the turning and the acceleration and deceleration in my game. In conclusion, I feel that things that went well were my moving forward, like the moving forward went well. Uh, Stopping went well, but I should have had it so that it could go backwards rather than just deceleration to a stop. And if I would have changed my turning so that my header was placed in the middle of my boat rather than at the back of my boat, I feel that would have worked better for me as well because the turning would have looked a bit more normal. But I felt the turning itself was good. Like the coding for the turning worked well. It was just the placement of my heading vector in comparison to the rest of my boat. These last few seconds of the clip will be of my references, so where I found all my information and all the helpful links and formula that I found to help me complete my game.